Welcome everyone. Welcome. We're delighted you could come out and join us today. You are signed on to the Precision Digital webinar titled LoopPowered Devices, the Fundamentals. And this is the second webinar in a three-part series that's all about 4 to 20 milliamp process signals. The webinar is designed as a basic course, and it's for those people who are not electrical engineers but need to be proficient in 4 to 20 milliamp because you deal with it, connecting devices and working with it on a regular basis. If you missed webinar 1, which was about webinar 1 was about 4 to 20 milliamp current loops and a basic course, you can still view that recorded version on our Precision Digital website. And we'll have a link in the last slide to that. But basically it's predig.com/webinars. So feel free to tap that for even more information. General housekeeping today, the most common question we get from attendees is, will we get a copy of the recorded webinar? The answer is yes. Everybody who registered gets an email within 24 to 48 hours, and it'll have a link to the recording and a link to the slides. Additionally, you'll be able to see this webinar recording on the Precision Digital website as well. Everyone is in listen-only mode, meaning you cannot speak to us directly through your computer or through your telephone. But we do encourage you to ask questions. Maybe you're wondering, how can I ask a question if I can't talk to you? Well, the answer is type your question in the chat window. You should see a chat window in the lower left-hand portion of your screen. Type a question in as soon as it comes to your mind. We'll be moderating questions, and we'll have 2 live Q&A sessions where we answer your questions live here during the webinar today. We do encourage you to ask questions. And if we don't get to your questions today, we'll get back to you after the fact. This webinar is being recorded, and once again, everyone will get a copy of, or an email with a link to the recorded version webinar. Speaking today, this webinar is presented and produced by Precision Digital Corporation. Precision Digital designs, develops, and manufactures a full line of digital panel meters and associated devices. We don't talk about the products in this webinar because this is an educational webinar where we talk about 4 to 20 milliamp signals, but we'd be delighted to hear from you if you have questions about the products. So feel free to give us a call or send us an email after the webinar and ask about those products. Or give us a call and ask about just information about this webinar if we can help you out. Speaking today, my name is Bruce McDuffie. I'm with the Precision Digital Marketing Department. I'm your moderator today, and today I'm speaking to you from Seattle, Washington. Ryan Shea is working behind the scenes. Ryan is helping with the chat window and interacting with you via chat. Ryan is an application specialist for Precision Digital, and he supports customers all day long, answering their questions about all types of connections and signals, including 4 to 20 milliamp loop power. Joe Ryan is your main speaker today. And Joe is a product manager with Precision Digital. He's an expert in process signals. He's got more than 10 years of experience in the design, support, manufacturing, and marketing of process measurement and control devices. Joe is your consummate expert in 4 to 20 milliamp. We're delighted to have Joe speaking to us today. Joe has extensive field and support experience with 4 to 20 milliamp loops and loop-powered devices. With that, I'll turn it over to Joe. Get started.
All right. Well, thank you very much, Bruce. So before we get too into the material today, let's just take a look at what we hope you take away from this webinar. First, we want you to learn the critical criteria required when you're using a loop-powered device. That includes what the specifications are going to be that are vital to it, a basic understanding of how the devices are going to function, and when it may or may not be the loop-powered device that's causing a problem in your loop. We also want you to be able to decide if loop-powered is your best choice for your devices. There's obviously loop-powered or 2-wire devices. There's 4-wire externally powered devices. And sometimes a loop-powered device is your best choice. Sometimes you're better off going with something that uses some form of local power. And we're going to talk about why you would choose one over the other. And finally, we want you to understand the application criteria that would just absolutely prohibit you from using loop-powered devices. So for those of you for whom loop power is a new concept, there's certain criteria that you're going to find in the field, and when you see it, you're going to know that, you know what, I don't even need to worry about that loop power stuff because I simply can't do it in this application, and I need to go on and find another solution. And it's good to know when that situation is so you can disqualify loop power from being an option for you. To do that, we're going to follow this agenda. First, we're going to define the characteristics of loop-powered devices. Again, those key specifications that you'll find on usually only loop-powered devices that you need to understand in order to be able to specify it for your system. And that's also going to be bring us right into the critical specifications for loop power, number 2. And we're going to talk about not only what those are, but what it means for your setup. Then we're going to discuss when loop powered is your best choice. So when you see an application, how do you recognize that really loop power would be ideal for this circumstance, and you should start researching that as your solution. And then by contrast, we're going to talk about when you look at your application, when do you know that this is not for you? Those criteria I mentioned earlier that instantly disqualify loop power as being a good solution for you. And before we get started with that agenda, Bruce, you had a couple questions for the audience.
Excuse me. Yeah, thanks, Joe. I know a lot of times in these webinars, it looks like you're the only person attending, but there's about 200 people attending today, and sometimes it's fun and interesting to find out who else is out there. So if everyone can vote, we'll first find out. I've got 3 short polls just so we get a feel for it. Where are you located? If you guys could vote, choose whether it's Eastern U.S., Central U.S., Western U.S., Canada, or something else. Even show the results as they come in. Always interesting. Looks like a lot of folks from the Eastern U.S. Welcome from us here located in the Western U.S. Joe and Ryan are both broadcasting from, or Joe is broadcasting from, is it Holliston, Joe? Massachusetts?
Yes, it is, Holliston, Massachusetts. That's about a half an hour southwest from Boston.
Right, a little east of Worcester, right?
Yes.
Okay, thanks everyone. Looks like everyone's voted who wants to. We can see Eastern, Central, and Western. Maybe there's something to do with the time. A few folks from Canada and then some others. Great, thanks everyone. Go on to the next one. Won't be too tedious with polls. Promise that. How about your industry? What industry are you working in today? Change from day to day. Who's participating in what industry? This is a topic that crosses many industries, or any industry where you have an instrument, of course, or some kind of device that may run on loop power. Watch the results come in, give everyone a chance to vote. Looks like a lot of industrial distributors here today. Manufacturing, and there's that other category. We had that in the last webinar. Have to help decide what other means.
If any of you are part of that other category and want to chat in some suggestions for what you feel might be popular industries, feel free to do so. Yeah, great idea. Okay, thanks everyone. There's the results. Last chance to vote. Like industrial distributors is the winner. Okay, and one more poll before we get started. What's your level of expertise? And this will help Joe tailor the presentation a little bit to the audience, even though we expect to see a pretty broad spectrum. But let us know what you think your level of expertise is. Or you could decide, you could share what other people think your expertise is if you like, whatever you think is more appropriate. You experts out there, great. Few electrical engineers, even better.
We know that we don't know everything about this topic, so if you have a comment about something we discuss or present, and if you don't agree with it, or if you'd like another perspective on it, please shoot us an email or type something in the chat. That would be great to hear from you. Like most folks, 40% nearly, enough to get the job done. Okay, I think everyone's voted. Thanks everyone for sharing that, and I hope that's helpful to the rest of you to see what the audience is like today. I'll go ahead and close the poll. And I'll move to the next slide and kick it back to Joe. Joe, it's all yours.
Thank you, Bruce. So the critical question here really is, what is a loop-powered device? And I'm guessing based on the poll results we just saw, a number of you have worked with these in the past, and you have a general sense of what it is they are and what they do. But let's just take a moment to review those fundamentals real quick. So a loop-powered device is a device that gets the power it needs to turn on and do its job from the system that it's connected to. So this is always going to be a 4 to 20 milliamp DC powered loop that it's being connected to, 4 to 20 being that industrial standard that I'm sure everyone in the audience has had experience with. And like any device, it needs power in order to turn on and do anything. If it's a level transmitter, it's going to need power to turn on and make the level signal be regulated, and it's going to need power to run whatever sensing element it happens to have. If it's a meter, like the kind Precision Digital would sell, then it's going to need power to turn on that LCD display and run a couple of open collector outputs and do whatever totalizing it may need to do. But obviously it needs to get that power to somewhere, or from somewhere. So what a loop powered device does is, using only the 4 to 20 milliamp loop that's sending a process variable, it uses that loop to power itself up. And you can see in the graphic on the right side of the screen, you've got a transmitter, which consists of a sensor, and then the transmit element. You've got some kind of process controller. And that really could be anything. That could be a meter. That could be any other type of device you'd be connecting to a 4 to 20 loop. And then you've got, in most cases, a power supply. And those are your three components of a 4 to 20 milliamp loop. The process controller, in this case, being a loop-powered device, doesn't have any other wires running to it. So if you look at the lower left, the example wiring for the PD6870, that's a loop-powered device. It's got a power supply and a transmitter that are in that 4 to 20 milliamp loop with it. And it's only got the two wires running into it. The S plus, and in this case the B minus, because it's being powered with a backlight, are the only two pins. So there is no direct power supply to device connection. It's taking all the power it needs off that 4 to 20 signal. Now, because it's being powered by that 4 to 20 milliamp loop, there's some unique characteristics that are going to come along with it being a loop-powered device. In order to understand what that is, I just wanted to talk very briefly about how a 4 to 20 works. We have a webinar that we did last week that's up on Precision Digital's website, predig.com, that you can watch if you want to, that will talk more about the basics of the 4 to 20 milliamp signal. So I'm just going to touch on it very briefly here. In the sample circuit we have VTOT, which is my power supply, and it's running a current loop I. You've got R1, R2, and R3, which represent any type of load. That could be a loop-powered meter. That could be a PLC. It could be anything else that is connected up to my 4 to 20 milliamp loop. Well, the current throughout all elements in this loop I is the same everywhere. So even though I have different voltage drops in the circuit at V1, V2, and V3, the current is the same everywhere. Well, in order to create power to run the device, it needs both voltage and current. The current is going to be the same everywhere in the loop. So it can't alter what that current flow is, or it's going to be changing what your process variable is. So what a loop-powered device does is it adds a voltage drop into the system. And that voltage drop is going to end up being one of those key specifications that we're going to talk about in a bit. So what are the characteristics of a loop power meter? Well, most of the characteristics are going to be drawn from the fact that this is an incredibly low power device. It's getting its power from a couple of volts drop on a 4 to 20 milliamp signal. Now to put that in perspective, if you plug something into your wall outlet in your conference room or by your desk, you're going to be able to draw probably something in the range of 15 amps out of that, and you're going to be pulling it at 120 volts. These devices are designed to run at 1 to 3 volts, possibly up to 18 volts, and they're drawing as little as 4 milliamps versus the 15 amps you're going to get out of your wall plug supply. So power is a real critical concern when these devices are designed. As a result, they tend to have some common features. They almost always have LCD displays on them versus an LED display. The LCD is that liquid crystal display like you see here in the picture on the left, that generally there'll be a gray background with the digit segments that can turn on or off that are very often fixed. There are, of course, graphical LCDs. You have them on your smartphones. But those all require more power. So generally when you're talking a loop-powered device, you're going to have to be okay with that static LCD display like you see in the photo there. Another feature you're going to find is that they have very few output options available. You don't have enough power in a loop-powered device to run an electromechanical relay or to provide an active powered 4 to 20 milliamp output. So generally what you'll see are open collector transistor outputs, which function similar to relays but are very low power. Instead of being able to switch, say, 120 volts at 3 amps, your open collector output may only be able to support 30 volts, and it may be as little as 20 milliamps or 150 milliamps. Similarly, you can have the electronics in the device that regulate current, so it can have a 4 to 20 milliamp output, but you can't drive it. You can't provide the power you need to run a 4 to 20 milliamp output by itself. So you're going to have some kind of external power supply connected to it if you're going to retransmit a 4 to 20 milliamp signal out of it. You're going to find that loop-powered devices have extremely limited serial communications options. When they do have serial communication, they're going to be slow-speed communications, and they may require additional power. A great example of areas that you'll run into issues would be, let's say, a Modbus communication setup. If a loop-powered device is going to talk on Modbus, it's going to need some kind of external power, and even then it may have slow-speed communications. Similarly, you'll get power over IP systems where, okay, it has an Ethernet connection, but it needs to have that power over IP in order to be able to run, or power over Ethernet. On the plus side, because they're such low power devices, intrinsically safe and non-incentive hazardous area approvals are very common on these. The design lends itself very easily into intrinsically safe and non-incentive designs. IS and NI are hazardous area approvals that are entirely based around the idea of the device itself never having enough instantaneous power in it to ignite the atmosphere, as opposed to, let's say, an explosion-proof device where you've encased something inside of a big metal shell to protect it, or to protect the area from an explosion. So if you need NI or IS approvals, a loop-powered device is a great place to start looking because there's oftentimes going to be versions of the product available with those approvals. And before we go on a little bit further, Bruce, you had another poll.
Yeah, thanks, Joe. Good stuff. We'd like to get a feel for your primary application. And if you could answer the question, which application or applications do you work with? You can choose all of these or one of them and choose multiple answers. Let's see what you guys are working in today. Maybe not today, maybe in general. A lot of flow, wow. A lot of flow, level, and pressure. Great. Perfect for flow, level, pressure applications. Temperature, humidity is one. I used to work in the humidity measurement business. Dealt with 4 to 20 milliamp loops all the time.
You'll find 4 to 20 just about everywhere.
What's the word? It's ubiquitous.
Yes.
Okay, looks like everyone is voted. Last chance, get your votes in. Okay, a couple more coming in. All right, I'll go ahead and close the poll. And interesting results. Great cross-section out there. And again, the same thing was we had 21% have other applications. Feel free to type in the chat what those other applications were. It would be really educational for us to know. Oh, we have a quiz. Hope you guys were listening. The question is, true or false? LoopPower fully supports LED displays. If you were paying attention out there. I'm not going to show the results as people type them or respond for this one because they poison the well, as they say. We'll wait a few minutes. You ponder if the quiz is, looks like we're pretty much getting it right. I'll go ahead and skip to the results. You have it. Correct answer is false. You people out there that admit they weren't paying attention, that's okay.
Well, we still appreciate the participation.
So you have to have been paying attention a little bit because you voted in the polls. Okay. Okay, yeah, the answer is false. And I believe Joe just covered that. And Joe, maybe a couple of sentences on why it's false again, just for those folks who
Sure.
are true.
So LED displays, which are that standard red digit display that you'll see on most industrial devices, require a fair amount of energy to run. They're very high light output, and obviously the more light you're generating, the more energy is required to do it. So because there's low voltage and low current powering the LoopPowered device, they don't have the energy budget to run those kinds of really bright displays. With a liquid crystal display, an LCD display, they have to provide a very small signal just to rearrange the crystals in the liquid that are what cause that digit to appear. So you can get away with having the same number of digits, the same size display, or even a bigger display for a much lower power budget.
Great. Thanks, Joe. Okay, we'll go ahead and move back to the presentation. Joe, back to you.
Great. So I mentioned earlier that there were critical specifications that are fairly unique to LoopPowered devices, and that they're really important that you understand them so that you can properly specify what device to use and to know that your setup is going to work. And the number one specification that people who don't work with LoopPowered devices often get confused on is voltage drop. So voltage drop in this case is a specification, and you're going to see it listed in some form or another on the product data sheets and maybe discussed inside the user's guides. It could appear in a couple different ways, and we show some here. You could see 3.0 volts max, or 3 volts at 20 milliamps. Or you could even see 150 ohm input impedance or 150 ohm equivalent resistance. Well, a 3 volt max is fairly self-explanatory. It's telling you that at most you're going to lose 3 volts from your loop. If 3 volts at 20 milliamps is there, it's telling you, well, at 20 milliamps you're going to drop 3 volts. Well, the basic equation for electronics is V equals IR. Voltage is equal to current times resistance. And so the maximum voltage drop is going to occur at the maximum current. So by saying 3 volts at 20 milliamps, they're letting you know essentially the same thing, that you've got a 3 volt max drop. Along those same lines, if you see something that says, like the example here, 150 ohm equivalent resistance at 20 milliamps or otherwise, you can do out a little bit of math and you can see that, well, okay, 20 milliamps is going to be my max voltage drop. I multiply that by my 150 ohms, and it's going to give me that same 3 volt drop. Now all of these are 3 volt drop, just to give you an example of how the same voltage drop could be displayed. But you might have a range of anywhere from 1 to 18 volts usually on what your LoopPowered device may drop. And it's very important that you know what all of the LoopPowered elements in your 4 to 20 milliamp loop have for voltage drop. I also want to note that you will get some more complicated devices that explain voltage drop in a more complicated manner. They might give you supply voltage versus equivalent resistance charts, for example. And in those cases, it's worth your time to sit down and look at that chart or look at that spec and really figure out what your max voltage drop is going to be, because you need to know that. The reason you need to know it is because the voltage drops of all of your loop-powered devices in your system have to add up to less than the DC power supply that's running the 4 to 20 milliamp loop. I'm going to say that again because it's a little tricky. The voltage drops of all of the devices in the 4 to 20 milliamp loop, and that's everything that isn't the power supply, have to add up to be less than what the power supply is providing. So I give an example here of a device that have a loop that has 4 devices. It's got a 24 volt DC power supply that's running it. Because that's my power supply, I know that I've got 24 volts to work with. I have a 2-wire radar level transmitter. And that's going to tell me in its spec sheet that it drops 12 volts. So right off the bat, I know that 12 of my 24 volts are going to be needed to run my 2-wire transmitter, which means that I'm halfway to my system failing. I have a loop-powered display, probably at the bottom of the tank in this example, and it's got a 3-volt drop on it. So again, at 20 milliamps, now I'm up to a 15-volt drop. And I've got a PLC. Well, the PLC is being used in this case to take in the 4 to 20, and then through some other method, pipe that back to my control room. But the PLC is externally powered. It's not a loop-powered device. It could be powered by 120 volts AC. It could be powered by a different 24-volt DC supply. But whatever the case, my PLC is not a loop-powered device. Because it's not a loop-powered device, it will have a voltage drop, but it's going to be insignificant. Most voltage drops for externally powered devices or 4-wire devices are going to be somewhere in the range of 0.2 volts. So unless you're really close to that power supply limit, in which case you have other problems of well, is your power supply really giving you 24, or is it really only giving you 22? What's the spec on the power supply for the minimum it can supply, things like that. Unless you're really close to your maximum that your power supply can provide, you only have to be worried about your loop-powered devices and what their voltage drops are. So in this case, with my 2-wire radar transmitter and my loop-powered display, I'm only at 15 volts. I've got 9 volts between my total sum of loop-powered devices and what my power supply is giving me. So I know I'm in the clear. If I were putting other devices on here that added up to greater than 24 volts or even got close to it, then I'm running the risk that my whole system is going to fail. Because the minute I get more voltage drop than my power supply can produce, my power supply voltage is going to drop. My current loop is no longer going to be properly regulated. My devices may not be getting the power they need to turn on. And I could get all sorts of unpredictable failures, from all of my devices going blank to the values they're reading being incorrect and unstable. And you'll start seeing some very strange behavior as the different devices try to figure out what's going on and how they can steal enough power to try to stay on. Another critical specification you need to spend time looking at are your output specifications. I mentioned earlier that because you've got a low power device on your hands, this loop powered device can't run mechanical relays. It can't run an active 4 to 20 milliamp output. So you need to figure out how to make your loop powered device run your other equipment. Let's say I've got a loop powered panel meter and I want it to turn on a pump. Well, if I'm relying on an electromechanical relay to trigger in order to provide power to that pump, I need something that can drive that relay. And well, I have no active digital output of any kind coming from my device. I can't bring the power right through the loop power meter because my loop power meter's open collector outputs are too small signal. They're not going to be able to support the voltage and current necessary. So I need to start thinking in terms of having an external power supply that's going to wire up with the open collector output to turn on a mechanical relay that is going to switch the pump on. So when you're using the outputs, you've got to be aware of how you're going to use them and determine what supplemental devices might be necessary to make up for the fact that your loop power device can't drive high power outputs. If you don't, you're going to find yourself in the field not able to run things, or you're going to put too much power through one of the outputs and risk damaging your device. Agency approvals. This one's actually a plus. As I mentioned earlier, because it's a loop-powered device, it's fairly easy to have those designs go and get approved for intrinsically safe or non-incentive approvals. And you can get those from any number of agencies. The ones we see most commonly are FM, CSA, and ATEX, though we also do IECIX, and other manufacturers provide equipment that are approved for a whole slew of different hazardous area approvals from around the world. So if you need something that's a Class 1 Div 1 device, you can start looking to see, well, hey, it's got intrinsic safety. It can probably do the same thing you might otherwise be looking for an explosion-proof device to do. So if you're used to using Class 1 Div 1 equipment and you think, well, I need to go buy a $2,000 explosion-proof device, it's worth looking at the specifications of LoopPowered devices and intrinsically safe devices because they probably have those same classifications. And a critical spec that I'm going to put here that a lot of people don't think about is the operating temperature range. As we mentioned earlier, LoopPowered devices are almost always going to be LCD devices, and that's liquid crystal display. And it really is a gel-like liquid inside that display. Because of that, that liquid can freeze. Especially on lower cost LoopPowered devices, you're going to find that usually below 20 degrees C, the LCD is going to start to fail. And it might fail by freezing up and just showing you whatever values on it permanently or until it thaws. It might fail by just losing contrast to the point where it becomes unreadable. But either way, you don't want some guy out in the field in minus 20 or below weather and finding out that he walked out there for nothing because now his display's gone blank. Or he's taking the wrong reading. There are LCDs that go down as low as minus 40, but they're not common. Precision Digital's got plenty of devices that do that, but you need to be aware of all of your devices. You may have a level transmitter, for example, that they only spec to go down to 0 because it has an LCD on it that isn't very good in cold weather. So if your operators are going to be working with these LCDs in cold weather, that's a specification you need to look at to make sure that it's going to work for whatever temperature zone you're in. High temperature, not a problem. The high temperature on LCDs can go upwards of 180 plus. That high temperature spec is going to be limited by the other electronics in your device. So that really has nothing to do with it just being a LoopPowered device. That temperature spec is going to be whatever it is for that piece of equipment, and it doesn't tie into LoopPowered devices in any meaningful way. But you do need to be wary of that low temperature spec when you're working on LoopPowered devices that are going to have LCDs. And Bruce?
Okay. Yeah, good stuff, Joe. A lot of good information there. I picture myself, I was in Denver last week. I live in Denver, and we had a low temperature of -1 a couple of nights there, and I can't imagine being out there trying to read an LCD and even -20.
No, you'll get some angry operators if they trudge out of their trucks and go out to an oil well somewhere in Canada and find out that nothing's working.
Yeah, absolutely. Okay, we got a poll, and see again if you have any comments or questions via this poll about those characteristics that Joe just went over. Which characteristic of LoopPower is most important to your application? Got some votes coming in. I'll show the results as they come in. The answers would be it does not need local power available, simple to install or wire, hazardous area approvals are common or usually lower cost. Voting coming in looks like does not need local power is a big one, along with their simple to wire. Surprisingly, lower cost is the lowest. We'll have to raise all our prices, Joe.
We'll keep that in mind.
Just kidding.
Not needing local power, though, is a big advantage. Anyone who's ever had to install these things in a field application is going to know that having to run conduit out to somewhere to carry wiring is time-consuming and it's expensive if you're having someone else do it for you. So only needing to run that 2 wires somewhere can be a big time and cost saver, especially if you're running those 2 wires somewhere else anyway. If you're running from your flow meter in the field to your control room with that 4 to 20 signal, well, being able to just patch a display anywhere along that line you want without having to run additional wire is a big advantage.
Great. Thanks, everyone. Looks like everyone's voted who has chosen to vote. And there's the results. No need for local power. and simple to install are the two top choices. Thanks for providing that feedback. We appreciate it. Now we have some questions coming in via chat, and I'm going to pose these questions to Joe now. We have Jim ask the question, what happens when a 4 to 20 active output is connected to a loop? I'm sorry, what happens when a 4 to 20 active output is connected to a loop already powered with a 24-volt DC power supply?
Well, you could be in trouble. So it depends on how things are wired. So to clarify Jim's questions for everyone, what he's essentially asking is he's got a 4 to 20 milliamp loop. And for the sake of this webinar, we'll assume he's got LoopPowered devices in it. So he has a 24-volt supply that's driving his 4 to 20 around the loop. Well, that is fine having an external supply like that if you have a passive 4 to 20 output on your transmitter. Because passive means that it doesn't provide its own power for the 24-volt. It doesn't provide its own power, rather, for the 4 to 20 loop. It needs that external power supply. So what he's asking is, well, if you have an active output, meaning that it's self-powering the 4 to 20, usually from an internal 24-volt supply, what happens if you accidentally set up a 24-volt power supply on there as well? And one of two things is going to happen. Either you're going to get lucky, and the power supply and the transmitter device can both handle that, and you're going to find that your system's going to run just fine. Or you're going to find that your transmitter can't handle that, and you're running the risk of actually damaging your transmitter. You could potentially damage another device depending on how things are wired, but you're most likely one of your two results is either going to be you're going to be okay because there's internal protections on the electronics that can handle that voltage level that you're trying to use to run your loop, or you're going to find there isn't, and you run the risk of damaging something. So my recommendation is you generally only want to use one power supply. If you have an active power supply from your device, that's great. You don't need to worry about a power supply. If you have a passive output from your transmitter and you're running LoopPowered devices or any other devices in your 4 to 20 loop, that's when you go and you get the external power supply.
Okay, very good. We have a question from Rebecca. She asks, so what are open collector outputs used for?
Great question. So open collector outputs are generally very weak outputs. They don't have their own internal power. They're essentially just closing a switch, a lot like a relay would be. They're just a dry contact that will close when triggered. However, because they're just small discrete electronics, they can't support the voltage levels or the current levels that a nice mechanical relay can, a nice solid relay with heavy-duty contacts and actual metal that's closing from an electromagnetic signal. Because of that, you only use the open collector outputs when you're doing digital switching of some kind. So a few common examples would be I want to read my 4 to 20 milliamp signal using a LoopPowered meter, and then I want to output that as a pulse to represent, say, a flow total or a flow rate to another device. And I can very quickly switch that open collector output much faster than I could in a mechanical relay. So you can use it for a high frequency output that would go to some other device, a PLC or a counter. Another way you might use it is exactly like you would use a mechanical relay, only you'd put something else in between. And that would be like the example I was giving where you have an open collector output that's controlling your pump. But what you're doing is you're using your open collector output with an external power supply to drive a solid state relay, where the solid state relay is an external relay that you purchased and installed. And so the low side of the solid state relay is what triggers the high side of the relay, and the high side of the relay is where you're running your pump power through. And then one last opportunity to use for it is when you're just bringing the signal directly into a PLC or some kind of data acquisition system. So you can use it like you would use a relay for alarms, but instead of supporting a high power application like turning on a siren or a large light somewhere to alert an operator, you're just running that open collector alarm right into a PLC digital input and then the PLC is handling what happens now that that alarm state has been detected. So there are uses for it. They just can't be any uses that are going to require direct high power interaction between the open collector output and whatever it is you're using it for. Hopefully that'll clarify it for you.
Yep, great. I clarified it for me, Joe. Good. We have a question from Russ, and this is actually kind of a common question we hear. Russ asks, we use 4-watt UHF handheld radios to communicate. Often causes spikes in our 4 to 20 milliamp readings. What is the best way to prevent RF interference?
That's a great question. And let me preface it by saying I would love to give you an answer that would absolutely solve your problem all the time, because I'm sure there are other people out there that have noise questions. Unfortunately, noise doesn't quite work like that. So I'm going to give you an answer, but I can't guarantee it's going to solve your problems. What I would do is I would double check the way in which I've got the device actually hardwired. So you want to make sure that you are somehow shielding those cables, because that 4 to 20 milliamp wire that you're using is basically a giant antenna. And so the best thing that you can do to prevent pickup on the 4 to 20 milliamp wires of that signal is to use some kind of shielded cable. Either you're running it through a grounded conduit, or even better, you're using a cable bundle with at least 2 wires in it where it's got its own internal shielded foil. And then you have to make sure that at each end of that you're grounding it to your devices, to your enclosures, to the pipes that you originated this coming out of, to the conduit it's coming from, etc. So the first thing you want to do is make sure you're somehow protecting your signal wires and that you're actually grounding that shielding, which oftentimes people will forget to do. The other thing that you want to consider is where your loop-powered device is mounted. You want to try to protect the device electronics itself. Because the device is such a low-power device, the noise from your radio might actually be directly affecting it rather than the wires. So if possible, if you're worried about noise, try to install the device in somewhere where it's going to be shielded. So if you're installing a level transmitter, well, hopefully it's at the top of a tank where your radios are going to get blocked by the metal of the tank. If you're installing a loop-powered meter, then you're better off putting it inside of a grounded DiMA-4X box rather than inside of a plastic enclosure where that radio wave is just going to go right through that plastic and inside the meter. So your best bet really is just to take really good grounding precautions and make sure that you've shielded it as much as possible. If the noise effects are very bad, there's other things you can look into. You can look into ferrites, for example. You could look into the possibility of getting a power supply that's a lot less noisy and just try to reduce the effects of existing noise, so hopefully your radios aren't going to affect it quite as much. But now you'd be grasping at straws. Your best bet really is just sound grounding principles in an attempt to shield it from the noise.
Okay, good. You know, Joe, we get these questions about noise. Maybe we set up a webinar all about noise and reducing noise.
I've been thinking that. I think a lot of people would find that handy.
Yeah, I think they would. Thanks for the questions, everyone. Keep them coming. Don't leave yet. We have some more slides, some more interesting slides that Joe is going to present, and then we'll have one more Q&A session at the end. Joe?
Actually, if I may make one comment based on a couple of input that we've had into the chat window.
Sure.
A few people have asked, based on what I just said, well, shouldn't you only ground one end in order to prevent ground loops, etc.? They're absolutely right. You only want to ground one end of the cable. When I say you want to make sure that you ground it on both ends, what I mean is that if you're running your cable, let's say, from a transmitter up on top of a tank to a loop-powered meter somewhere, you want to make sure that there's a seamless ground from your single point ground through the wire to the enclosure that you're running the loop-powered meter into, or some such along those lines. You want to make sure that you've got a grounding connection everywhere and that you don't just connect up your shield wire to your box but then not actually have your box grounded anywhere.
Great. Thanks for clarifying. Move on. We've got about 15 minutes left today, and we want to make sure everyone keeps schedule, especially us. So, Joe, pros and cons, it's all yours.
Great. So when is LoopPower your best choice for a device? Well, it's got some great pros. It's a simple, easy way to display a 4 to 20 milliamp transmitter signal or to install the actual 4 to 20 milliamp transmitter. As we've said, it's a 2-wire device. You don't need to have power where you're trying to connect it up. And generally they're going to be simpler devices because they're not going to have a slew of high power outputs, so they can even be easier to program. All of that simplicity makes it an excellent choice for just about any industrial installation, because I've never found someone looking for a more complicated device to wire and set up. It's also a low-cost solution for display or even for transmitting. Because it's a 2-wire device and because it's such a low-power device, it lacks a lot of the high-cost power supply elements that you're going to find in 4-wire devices. Because it doesn't have an expensive power supply in it, there's a lot of savings that gets passed along to the customer. So generally you'll find that a LoopPowered device is a lower cost item than something that's 4-wire that's the equivalent. And it's great for agency approvals. Not only is it a lower cost option because you can get the similar approvals only intrinsically safe or non-incentive, so you don't have to pay for the giant metal housings that you would for, say, explosion proof. But it's a way to get devices that you can use in both hazardous area and safe area. Oftentimes, like with our loop leader panel meter line, we'll have an approved version of the product and an unapproved version of the product. So you get to know one, you know them both, and you only pay for the approvals when you need it. There's definitely some cons with LoopPower though. You've got very limited output options. And that comes from the fact that this is a low power device. We've talked about how it can't support relays, and you will generally be stuck with those open collector outputs, which are great for some applications but not for others. If you have operators that really want to have that stereotypical LED red display like you find on most instrumentation, they're not going to be able to get that. Similarly, if they want some kind of touch panel or graphical LCD, you're not likely to find that either. Along the lines of the relay issue, you only get passive analog outputs. So if you're looking to retransmit that 4 to 20 milliamp signal to somewhere else, well, you're going to need to buy a power supply to run that loop, because you can't get a self-powered 4 to 20 milliamp output off of a 4 to 20 milliamp output, or off of a 4 to 20 milliamp loop-powered device. You've got limited display variety. I already mentioned that one, the idea that you really are just looking at those LCD displays, the basic variety. And then you've got limited serial communications. Now I know someone will mention HART, and that's true. LoopPowered devices can work with HART. But once you're out of the world of HART communications, you start being extremely limited, because all of that high-speed communication is going to require a lot of power. Then there's the voltage drop and power supply considerations. You need to have a power supply that can support all the loop-powered devices in your 4 to 20 milliamp loop. So if you only have a 9-volt supply available to run your 4 to 20 loop, or your active power or your active 4 to 20 out only drives 12 volts, you may not have enough voltage available to run all your devices as loop power. And we have one question here for you about the cons that we just talked about.
Yeah, we would like to get some feedback from the folks here on which of those cons that Joe just described would prevent you from using a loop-powered device. Choose one of those if it would prevent you from using loop power. Back for the audience. Go ahead and show results as they're coming in. What the answers would be: the voltage drop is too high in my application, or lack of mechanical relays, or lack of powered 4 to 20 milliamp output. LCD, not LED, is the interface, and limited serial comms. And I think you can pick more than one on this. Be able to pick more than one. Votes are coming in. Thank you, everyone, for the feedback. Like lack of mechanical relays is the winner leading reason why people might not use powered devices. Voltage drop is too high is tied with lack of powered 4 to 20 milliamp output. LCD, not as big of an issue. Serial comms, not as big of an issue. Leave it open for a few more seconds here. Last chance to get your votes in. Go ahead and close the poll now. Thanks everyone for participating in that. There's the results. Like lack of mechanical relays, biggest one. Okay, thanks again everyone. Joe, back to you.
So we've just got a few more slides here to wrap up, and one of those is going to be an actual real-world application. And this kind of helps highlight when that loop-powered device is going to be your best choice. So the 2 meters that you see here on display on the right are from a tank farm. However, they're not actually next to the tank. They wanted to be able to display that storage tank information, but they didn't want to have the operators have to be next to the actual tanks to see it. It's a hazardous area in oil and gas, so they don't just have access to all of their wiring everywhere. It's expensive to run, and they need to run it through special conduits. So they didn't have power wires available where the operators wanted to see the level. Also, the installation's outdoors, and as I mentioned, it's in a hazardous area. So LoopPower was a great solution for this application. They were able to get their 2-wire loop-powered level displays with hazardous area approvals. In this case, they got them in explosion-proof enclosures, but they're still a 2-wire device. And install it here without the need to run additional conduits in order to bring up power. So they essentially just brought they were bringing the 4 to 20 milliamp signal elsewhere anyway, so they brought the conduit up, installed their 2 meters, and with 2 wires for each with 2 wires for each meter, they don't have to run any additional conduit, they don't have to run any additional power supplies, they don't have to worry about barriers to bring in power from outside the hazardous area. They're done. They wire those few wires up, and now they have a great solution to get the display where the operators want it. So given all these pros and the good examples of when LoopPower is going to be used and why you would use it there, let's just review quickly when you wouldn't be able to use LoopPower. So those applications where, well, unfortunately all those pros don't matter because it's just not applicable for you. The first one's going to be that you need that LED or that graphical LCD display. That's what your spec is calling for, and that's what your operators want to see. LoopPower is not going to be the best choice for you because it can't support it. If you need high power outputs, you need relays that can support pumps or motors, or that need to be able to drive sirens or safety equipment. Or you want a 4 to 20 milliamp output that's self-powered, so you don't need a power supply for it. But again, LoopPower is not going to be for you. If an external power supply is required in the transmitter or some other piece of equipment that is right nearby where your display or transmitter is going to be, then you don't have to use LoopPower. If power is readily available for you, unless you're looking to save cost, there's really few advantages to going with LoopPower. If you have a requirement for serial communications like Modbus or Ethernet, then again, you don't have the power in LoopPower devices to run that, and you may find that it's more hassle than it's worth to try to shoehorn a LoopPower device into that application. You get an externally powered device, and it's going to be able to directly connect up to your 4E5 or your Ethernet line. In extremely cold temperatures, you need to be wary of it because you have an LCD on it. You can use it, but make sure the data sheet from whoever the supplier is for your piece of equipment, make sure that data sheet says it can support the temperatures you're likely to run into. And lastly, if you don't have a 4 to 20 milliamp current loop, then you can't use LoopPower. LoopPower, by definition, is used in 4 to 20 milliamp DC loops. So if you're trying to read a pulse output from a flow meter or an RTD or thermocouple signal, then you're not using a LoopPowered device. You would need to go get some kind of transmitter in order to bring that signal into the 4 to 20 milliamp world in order for the LoopPowered device to work with it. So what did we look at this afternoon? We talked about the definition and characteristics of loop-powered devices. We talked about the critical specifications like voltage drop that you need to be aware of if you're going to work with these. We looked at times when loop power is going to be your best choice. And we talked about those criteria that are going to let you know that loop power is not for you immediately based on what your application requires. And Bruce,
Okay.
question.
Yeah, we have one last poll. I hope we didn't kill you with these polls. But if you have feedback that there's too many polls, we'd want to hear it from you. I think it helps. I think it keeps it a bit interesting. So the last one we have, how often do you specify digital displays? Don't worry, this isn't a sales trigger for our sales team. This is just for information. So feel free to vote. Skip to the results so we can see what's coming in. 10 times per year. By far the most popular choice. Never specify them. That's okay. We're glad to have you learning about 4 to 20 milliamp power, loop power rather. I'll give it a couple more minutes. I'm going to be a little quicker on this poll because we're running out of time and we have a couple of questions I want to get in. So
thanks for sticking with us, everybody. I know we're running a little over our planned time period here.
I'll go ahead and close the poll. So look at the results. Bell curve. Thanks everyone for voting. And we do have some good questions coming in. And try and keep the short answer questions, Joe, so we can get more than a couple in. We only have
I will do my best.
Okay. Question from Derek. Do you need to factor distance in when you're considering voltage drop?
The short answer is no. You'll find the answer to that question talked about more in depth in the first webinar in this series, which we mentioned earlier is available on predig.com. But the long story short is the voltage drop of wire is going to be so low that you'll almost never run into that being your problem. You could run it several thousand feet, and I can almost guarantee you you're not going to have to care what that voltage drop is.
Okay. Here's one from Bill. Bill would like to know, I was wondering this question myself when I saw the slide. What is a good reserve to keep after the voltage drop? In other words, you know what I mean? Yeah.
Yep. The reason you want to keep that reserve there is for two reasons. One, to accommodate the small voltage drops in non-loop power devices. And two, because you're going to get some fluctuation in your power supply. I would generally say that whatever your power supply is rated for, so let's say you have a 24 volt supply, you want to keep a 10 to 15% limit on how much space you give yourself between what your voltage drops add up to be and your power supply is. So if I have a 24 volt power supply, I'm going to try to give myself 3 or 4 volts of headway just to make sure I don't run into a problem once I start loading this down. If you start approaching that range, check the specifications on the power supply. It will generally tell you how low it could potentially drop. It will give you, well, this is a 24 volt power supply plus or minus 10% or some specification like that. And that will let you know really how close you can get. But to account for all of those little voltage drops that might add up, like the wire drop or the externally powered device drop, I usually try to give a little more than that, like 10 or 15.
Okay. Thanks everyone for the questions. We have a few that we did not get to address, but we'll get back to you via email on those. Next webinar is on December 9th, same time as this one, 11 o'clock Mountain, 1 o'clock Eastern. And the title is Loop versus Line Power, Understanding 2, 3, and 4 Wire Signals. So we're going to talk about, it's an introductory class again. It's not an expert level class. We'll talk about the differences and the pros and cons of 2-wire versus 3-wire versus 4-wire and definitions, and help you determine which is the best choice in a similar fashion we talked about loop power. Hope to see you there. Everybody who registered for this webinar will get an invitation probably in about a week to this next webinar. Hope to see you there. Again, consider Precision Digital if you have as your source for loop-powered meters, digital panel meters, explosion-proof instruments, large display meters, and others. And finally, contact information. give us a call, shoot us an email, or check out the website. We've got answers to your questions about education and 4 to 20 milliamp and other process signals. And check out the website, www.predig.com/webinars, and you can watch this webinar and webinar number 1 at your convenience. Thank you. This is Bruce, Ryan, and Joe signing off. Have a great day.